So, hi Naukri Learning viewers. We have yet another video in the field of cybersecurity. And today we are going to discuss a complete understanding of network security. We'll discuss about networks, network models, why and what is network security, different types of models, and so on and so forth. And for this, we have Devashish Acharya, who will be presenting today. He has more than 12 plus years of experience and is a thorough cybersecurity professional. Once you watch the video, if you guys have any question at the end related to the topic, then you can share in the comment box below, and we will try to get back to you through our comments. Also, subscribe to Naukri Learning channel because we will keep having more such learning content. So, without any further delay, let's get started. Over to you.
Thanks, Niharika. Hello, viewers. So welcome to the session. My name is Devashish, and I have overall 12 years of experience in the IT industry, diversified into cybersecurity, cloud, and DevOps domains. So in this session, we are going to cover complete understanding of network security. So I'll be covering on taking you through most of the aspects of the network security, how to secure a network, basically, right? So this is the how the agenda looks like. So we will take a look at what is a network, and we will also go through the network models which are commonly followed, the OSI and TCP/IP ones. And so what is a network security, and why do we need network security, right? And further we will also take a look at network security at various OSI layers, and we will also discuss about defense in depth as well as some of the controls, so cybersecurity controls that will ensure network security, right? So before getting into network security or before discussing about how to secure a network, so let's know what is a network, right? So network is basically two or more computers that are sharing information and other resources such as an internet connection, an application, a printer, etc. Right? So if they share all these resources with each other through a wired or wireless network, then or wired or wireless medium, basically. So then that can be called as a network, right? And the internet is the largest network in the world. So most of you or all of you must be using internet, right? So on the next slide, we have an example of a local area network. So local area network looks like this, wherein we have various network devices, like on the top of the image, you can see a printer, servers, and desktops, right? Then we have Wi-Fi router, which helps connecting the laptop and mobile phones, which are basically handheld devices to the internet, right? So the wired channel goes through a network switch onto the router and over to the internet. So this is an example of LAN or local area network. And a wide area network, so basically it is a collection of multiple local area networks. So the LANs basically connect or interact with each other through the internet, right? So basically wide area network is a collection of multiple LANs, and internet is the largest wide area network in the world, right? Okay, so next we have OSI model. So OSI model, as most of you might be aware, OSI stands for Open Systems Interconnection. So it was developed by the International Organization for Standardization, which is ISO, in the year 1970s, and it is the most widely used network model in the world, right? And it has 7 layers. So basically, as you can see, starting from application layer and onto the physical layer. So this is how the OSI model looks like. So the layer 7, it basically the function is that the end users interact with the application through this layer. So the data format in this layer is protocol data unit or PDU, right? So once when the users interact with the application through the layer 7, so the data goes to layer 6, which is the presentation layer. So presentation layer basically is responsible for making the data OSI compatible, right? And it also performs compression as well as encryption on the data. And the data format remains same, which is protocol data unit. Then on layer 5, which is session layer, it is basically responsible for establishing such connections. right? So through the use of appropriate ports, and it also responsible for maintaining the user sessions. So session is basically every session or every interaction of an end user with the server is managed by unique session. So session is unique to every connection. It is limited and it can expire. So those connections are basically established by the session layer. Then we have layer 4, transport layer. It is a very important layer. So the function of the transport layer is that it controls the session. So layer 5 creates the session, whereas layer 4 controls the session, and it also ensures the integrity and delivery of data. So the data format at layer 4 is segment, which is followed for TCP model, whereas for UDP protocol, the datagram data format is followed, right? So TCP and UDP, basically the differences: TCP stands for transmission control protocol, and layer 4 and or the transport layer basically ensures the delivery of data if it is transmitted through a TCP protocol, whereas UDP ensures it does not ensure data delivery. It is responsible for transmission of data on a best effort basis. It does not guarantee delivery, right? Okay, so moving on to network layer, which is layer 3, right? So the function of network layer is routing. So network layer finds the best path or the best route, and it routes data to the appropriate destination, right? So data format in this layer is packet layer. No, I'm sorry, the packets is the data format. Basically, the data is transmitted through the network layer as packets. And moving on to the data link layer, which is layer 2. Here, the packets are formatted and converted into frames, right? So because from network layer to data link layer and further down to the physical layer, so data will be converted from packets to frames, and again at the physical layer it will be converted to bits. So basically layer 2 data link layer, it formats the packets, convert it to frames, and the physical layer, which is the last layer, layer 1, so it transmits the data over a wired link. So that is all about this OSI model. So it is important to understand this in order to ensure network security, because this is the most widely used and secure network reference model. So we have another model called TCP/IP. So TCP/IP model is also widely followed, but it was actually developed by the U.S. Department of Defense. It exists even before OSI model. But basically, TCP/IP model was developed for ease of use rather than for security. So for security purposes, mostly we follow the OSI model. So as you can see, the corresponding layers of OSI model, there are 7 layers in OSI model, whereas just 4 in TCP/IP model. So color coding, I have done color coding here. So the top 3 layers of OSI model, are the counterparts of the first layer or layer 4 of the TCP/IP model, right? Similarly, the layer 4 of OSI model corresponds to the layer 3 of the TCP/IP model. Then layer 3 of OSI model, which is network layer, corresponds to layer 2 of internet layer, layer 2 of TCP/IP model, which is internet layer. And the last 2 layers of OSI model, which is layer 2 and layer 1, so they correspond to the layer 1 of the TCP/IP model. So this is how the layers are arranged in OSI model as well as in TCP/IP model. Yeah, but another important point. So further in this session, we will be referring the OSI model as it is more secure. Okay, so in this slide, so what is network security? Basically, network security is the concept of protecting the confidentiality, integrity, and availability of computer networks and the data that passes through them, right? So confidentiality, integrity, availability, or the CIA triad, as it is commonly referred to as. So we will be taking a look at the CIA triad further in the next slides. Yeah, network security is basically the concept of protecting the CIA of the computer networks, and the data. So network security is achieved through use of various tools, technologies, and processes, and of course, people as well, right? So moving on. So why do we need network security? So the need for network security. So let's take an example here. Let's say a sender is trying to send a message to the recipient, right? And you have a hacker or an intruder sitting in between who is able to read the messages, right? So what will happen in such a scenario? I mean, if the hacker gets a hold of the data which is being transmitted from sender to recipient, what will happen? So the impact of such an intrusion or such a leak could be monetary loss due to data leaked to a competitor. Competitor can use that data to their advantage, right? There could be legal implications wherein the sender organization can be, fined by the law enforcement for violating the compliance, right? They may be liable to pay damages to a third party if somebody, files a or sues the sender organization for not being able to protect the data, right? And it could also result in reputational loss for any organization, and also distrust by existing employees as well as potential employees, right? Or distrust by existing customers as well as potential customers, right? So this is the need for network security. Basically, to avoid such consequences, we should protect the data while it is being transmitted from the sender to the recipient. So the solution to such a data leakage or the potential data leakage is that when the data is being transmitted from sender to the recipient, so we can lock the data. So how do we lock it? We can put an encryption. We can apply encryption to the message while it is being transmitted, right? And also we can secure the channel. So we can also encrypt the channel so that nobody will be able to intrude into the channel or read the messages. So if the messages are encrypted, even though somebody gets hold of the messages, right, or somebody gets a copy of those messages, then they will not be able to read it because the message is encrypted. It is not in readable format. Only the recipient will be able to basically read the messages by decrypting using their private key. So we will discuss further in this session about the keys or the ways to encrypt data, right? Okay, so this slide talks about the CIA triad as we discussed, in one of the previous slides. So CIA stands for confidentiality, integrity, availability. So these are the key principles of information security. These are also applicable to network security. So confidentiality basically ensures that only the authorized entities should be able to access the data. Okay, so that too on a need to know basis. So basically, the person who has a need to know the data or who is authorized to read the data, they should be only able to access that data. And integrity, so the second one in the CIA triad, integrity basically ensures that unauthorized alterations should be should not be made to the data, right? So this ensures that the data is reliable and accurate. So basically, whatever the data is, created or generated by the sender, it should be same as it is delivered to the recipient without any unauthorized modifications on the way from the sender to the recipient. So that is integrity. And availability, the third one. So availability basically ensures that only that the authorized entities should be able to access the data whenever they need it, right? So whenever the need, as and when the need, they should be able to access the data, right? That's about availability. And an example of availability is that network should be protected from DOS attacks. DOS basically stands for denial of service. So we should protect the data from, DOS attacks. So that's an example of ensuring the availability of the network. Okay, so next few slides we have the network security being applied at various OSI layers. So we have network security at application layer, that is achieved through PGP, and network security at transport layer, that is achieved through TLS, and also network security at network layer, which is achieved through IPSec. Okay, let's take a look at these three applications of network security. So basically, network security at application layer, PGP. So PGP basically stands for pretty good privacy. Okay, this is the most widely used email security standard in the world, right? And it was founded in the year 1991, and after that it has gone through multiple iterations, and right now the commercial product is being sold by Symantec, and there is also an open source variant which is called OpenPGP, that is open to anyone who wants to use as per the uh, you know open source terms, right? So the fundamental uses of PGP are encrypting emails and files, right, and also digital signature. So encrypting emails and files, it is pretty straightforward that we are trying to protect, the confidentiality of the emails or the files while they are in transit, right? And also digital signature, the concept here is the digital signature basically ensures the authenticity and integrity of a message, right? So authenticity means the signer is confirmed. That means we are able to, whoever is signing a information or message with their digital signature, so we are able to validate that, the identity of that person. So that's authenticity. And non-repudiation is basically the person who signs the message, they cannot deny that they have not sent it. Okay, it also ensures or avoids impersonation, so nobody can impersonate somebody if there is a digital signature applied to messages. Okay, in this slide, this is a pictorial representation or a diagrammatic representation of how PGP works. All right, so the use case here is that the user A is trying to send a message to user B, right? And over a over the internet or over a public network, and the email is encrypted using user B's public key. Now, so A is the sender and B is the recipient, and A has access to user B's public key, right? So this is called asymmetric cryptography, wherein user B's public key is used to encrypt the email that is being sent by user A, and then it is transmitted over to user B. So user B has their own private key, so they can decrypt the message and read it using their own private key. Right? Now you must be, worrying, or question might be coming to your mind that how user B's public key is available with user B, which is perfectly fine. That is how asymmetric cryptography works. So user B can share their public key with anyone they want to receive a message from. So user B sharing their public key is absolutely fine, right? So that is why the name public key, which is meant to be public, whereas user B's private key, they have to retain it. So this is how the PGP works and ensures the application layer security for email applications. Okay, so next we have network security at transport layer. So there is something called TLS, which stands for transport layer security. So TLS is basically the successor of SSL protocol. Most of you must be aware, or most of you might be still referring, the TLS as SSL, but SSL actually has been, deprecated, and it is no more in use, wherein it has been replaced by advanced and more secure version, which is called TLS, right? And TLS is widely used for web application security. So basically, by encrypting connections between a browser and the server. So whatever transactions, whatever browsing that we do on the internet through an HTTPS website. So website whose URL starts with HTTPS. So all those websites are actually using TLS. So to secure the connection and secure the communication between a browser and the web server, right? And TLS is basically responsible for encryption, authentication, as well as integrity. So this is basically a diagrammatic representation of how the network security at transport layer works, or the TLS, how basically the TLS works. So here we have a web browser client, right? and which is interacting with a web server, right? And also we have another entity here called certificate authority or CA, right? And the step one, the user tries to access a website over HTTPS www.example.com, right? And the step two, the server or the web server responds with its TLS certificate as well as its public key, right? So in step three, what happens? The browser will validate the certificate with the CA and confirms the identity of the server, right? So basically, the validation that happens here is the web server, whoever it is, saying it should be the same server. So that is what the authenticity of the server is being validated, and also if whether the certificate is valid, basically it is not expired or it has not been revoked. So those kind of checks are also done by the web browser with the certificate authority. So once the step three is done, once we are good, then on step four, the browser generates a unique session key and encrypts it with the server's public key. So if you remember, server had shared the public key in step two. So in step four, the session key which is generated by the client is encrypted using servers or web server's public key, and it is sent to the web server. Now web server decrypts the same session key using its own private key, right? And then in step five, what happens? The further communication between the web server and the client happens, over the internet, but the connection is encrypted using the symmetric session key. Now here we have the use of both asymmetric cryptography as well as symmetric cryptography. So in the step two, as you can see, we are using asymmetric cryptography, right? And wherein the web server is sharing its public key, and in step four, the same public key is being used to share a session key with the web server. Web server uses its private key. So till step four, it is asymmetric cryptography. But in step five, you can see or the further communication that is happening between the browser and the web server is using a symmetric cryptography, wherein the unique session key is available with the web browser as well as with the web server. So this is how the TLS works. And uh, so to show you an example, when you access a website which is TLS enabled, right? So you can see a padlock symbol over there in your browser, address bar, right? So this basically ensures that this website uses TLS and it is safe to interact with the website, and yeah, that ensures the network security at transport layer. Okay, so next we have network security at network layer. So network layer is basically the third layer, the layer 3 in the OSI protocol, and also it is responsible for routing the information from the sender to the corresponding recipient, right? It also ensures the best route path. So IPSec is a protocol, or you can also call it a framework. So IPSec basically stands for Internet Protocol Security. So IP or Internet Protocol is the main routing protocol used across the internet. So most of the modern applications they use IP routing protocol. So that is used over the internet, and also IPSec is widely used for setting up VPNs. So most of you in this COVID era we are working from home, so we are using VPNs extensively to connect our laptop to the corporate network. So IPSec is being extensively used in this space to set up VPNs, and it is also basically responsible for encryption and authentication. So authentication as in, so it is this IPsec is responsible for you know uh, proving the identity of the end user device or the laptop to the corporate network, and also it validates the identity of the corporate network to the laptop, right? So that way the two-way authentication happens, and then a tunnel is set up, and encryption, basically the encrypted tunnel or the secure tunnel is being set up between a laptop and a corporate network. So that is where we ensure network security at the network layer, right? Uh, and moving on, so we have another slide on network security at network layer, which is IPSec. So this basically IPSec has two main components. So it's an authentication header is one component. The other component is encapsulating security payload. So AH, which is the first component, it ensures the message integrity and non-repudiation. So message integrity is ensured basically by ensuring that the message is not tampered with on the way from sender to recipient. And non-repudiation means when the recipient or the sender is sending the message, it signs the message with their own key, and nobody, and they cannot deny later on that they have not sent this message. So that is non-repudiation, and it also ensures impersonation. So impersonation does not happen. It ensures that, right? And ESP, which is encapsulating security payload. So this ensures the confidentiality of the packet contents. Basically, the contents of the message is encrypted by this component, right? ESP. So moving on the second half of this slide, we have the modes of operation of the IPSec. So IPSec has two modes of operation. First is transport mode, which ensures end-to-end encryption. Basically, this is used for encryption between two hosts, so or peer-to-peer, right, communication. And here in this transport mode, only the payload is encrypted. Header is not encrypted, whereas in tunnel mode, which is also called link encryption, the payload plus header both are encrypted. And this tunnel mode, another important point to remember is that tunnel mode is mostly used for our VPN connections that we use to connect to our company networks. Okay, so that's it about the network security at various layers of the OSI model, right? Now we have something called defense in depth. This is a very important concept when it comes to network security or information security for that matter. And so defense in depth is basically a concept of using multiple products and also best practices to protect the network from cyber threats, right? So the primary goal of defense in depth strategy is that if one security product or one security control is bypassed, then the other controls act as a backup to protect the network from cyber attacks, right? So let's say we have three, controls. So first control is basically the first layer of defense. If that fails, we have second layer of controls. Then we have another third layer of controls as well. Or basically the layers or the number of controls will depend from or vary from organization to organization. So in defense in depth, we have three set of controls. So broadly categorized into physical, technical, and administrative controls. So in physical controls, so basically this ensures the physical security of data centers and the IT assets, as well as the offices of any organization, right? So it ensures that theft or damage to the physical assets of the company does not happen. So the tools used here are ID card readers, biometric readers, biometric scanners, right? CCTV cameras that are used for monitoring, and security alarms that will go off if there is an intrusion into the physical boundary of an organization. Fence also ensures that nobody will be or prevents intruder from getting into the physical space of an organization, right? So that's about physical setup controls. Next, we have technical setup controls. So these are basically the IT tools that are used to protect the network from exploitation, right? And the tools that are used to implement technical controls are firewall, right? This is a very, very important concept, component of network security. Then we have IDS, IPS, intrusion detection system, intrusion prevention system. Then we have proxy that ensures that nobody should be able to access any unauthorized or malicious sites. And antivirus, anti-malware, very, very famous technical control. that we use on our endpoint or personal laptops as well. Then we have something called EDR, which stands for endpoint detection and response. That ensures that if some intrusion happens, if some malicious files are getting into your you know machine, into your laptop, and they try to do something you know unusual, then EDR kicks in and they try to prevent such malicious activity on endpoint laptops or endpoint desktops or servers for that matter. Then DLP stands for data loss prevention. Again, another important concept that companies' confidential data or intellectual property information should not be exfiltrated out of the company network. Then web application firewall is again another important component which ensures the security of the web applications by blocking malicious traffic, malicious patterns, or signatures. Right. Then database activity monitoring, another aspect mostly used for regulatory purpose, but yes, it has good controls to ensure the safety or the security of the databases and also prevents any unauthorized unusual activity on databases. Uh, so that's our technical controls and administrative controls. So these are basically the policies and the initiatives to spread security awareness, the cyber hygiene that is being followed by the employees of the company. So that makes the administrative controls being followed by an organization. Uh, so we have a few more controls. So another set of controls which is called preventive, detective, and corrective. So as the name suggests, preventive control basically helps in preventing any cyber attack. Detective controls help in detecting those cyber attacks if those are not prevented by the preventive controls, right? And then corrective controls, basically if we detect something, let's say we detect some malicious activity, those have already happened. So if we detect, then we should be able to correct or take action or respond to those malicious activity or cyber attacks, right? So that's the role of corrective controls. So on the in the preventive control set, we have IPS, intrusion prevention system, firewall, WAF, and so on. In the detective set of controls, so we have intrusion detection system. So you can see the difference between IPS, which is intrusion prevention system, and IDS, which is intrusion detection system, which is in detection mode, monitoring mode. So it will not block anything. So firewall, again, if it is not in block mode, it acts as a detective control, and there are more tools as well. And this IEM stands for Security Information and Event Management. It's a very, very important tool, mostly used in the SOC or Security Operations Center. So this is also, plays a big role in, detecting malicious activity. So the last one is corrective control. So once we detect something, then we have something called a SOAR, which is growing in an unprecedented manner in the market. So SOAR is a concept which basically helps in automating the security response, and it also takes a lot of load from the security analysts or other engineering teams in responding to cyber attacks. Then we have automated scripts as well as manual response methods as well. Those have been traditionally used across the network operations center and security operations center setups. So yeah, so that's it in this session about complete understanding of network security. I hope you find this useful. Thank you for watching.